Okay, so previously we have discussed about what is potential difference. So we also called voltage for potential difference, and we have also discussed what electric current is. And I have said that it is very important to understand potential and potential difference and current, and then later on we are going to develop a relationship or learn the relationship between voltage and current. So today we are going to go with Ohm's law, which basically gives us the relationship between the voltage and current. Okay, to talk about the statement, it is very simple. So we can state Ohm's law as the current flowing in the conductor, which is directly proportional to the voltage applied across the conductor, provided all the physical conditions kept constant. Okay, so basically what this law is saying is that we have learned about the potential difference. So that means, so if I have two plate like here, if I'm going to bring more charges here, then uh, I will have more potential difference, so which we have previously discussed. Okay, so let me make two plates out here. So in the first plate there is five charge, you can see. So in a second plate I will make just seven charges just to show it is greater than the first charge. So this will be in the higher potential and this will be in the lower potential. Okay, and the charges is going to flow from higher to lower potential, higher to lower potential. But if you compare the potential of these two plate A and B, then you know that VA potential of A will be, sorry, so will be lesser than the potential of VB, because there is less number of charge in plate A as compared to plate B. So therefore the current in this case will be greater according to the Ohm's law. Okay, so more potential difference you give, the current is also going to increase in the circuit. Okay, or in the across the conductor. Okay, so now let us remove this all, and I will make a simple circuit out here. Okay, simple circuit out here. So let's consider you have we have a circuit like this. Okay, so and then this is 2 voltage of potential difference, and then the current will be flowing from the positive to the negative terminal as discussed earlier. And I have another circuit. So here the voltage is 5 volt. So then if you are asked in which of these two cases the current will be higher, so then according to the Ohm's law you can directly say that if the potential is higher, then the current will also be greater. Okay, so that means if you increase the potential across the conductor, so then the current in the conductor will also increase, and they are proportional. Okay, so then if we have to write a mathematical equation, then we can say that this current I is proportional to V. And we also know that whenever we remove this proportionality sign, we have to use a constant, and in this case this 1 by R is our constant. Okay, so then further it can be written in this equation: I is equals to V by R, or V is equals to IR. Okay, so uh, this equation you will see everywhere. Okay, so but I have written in other way also. This also works as well as this equation. So anyways, so here you will see a new term which has been introduced in a constant, that is this R. Okay, so this R here is known as your resistance. Okay, so R is known as your resistance, and resistance, to define resistance we can say, is the obstruction to the flow of current in the conductor. So let us understand what does this mean? What does the resistance in a circuit means? Okay, so a resistance means, so see, I have considered two conductors. Okay, you can see these two conductors are same in lengthwise and the cross section area wise. You also know that the conductor contains of free electrons, which is responsible for current. Okay, and when you apply potential difference, this electron goes from one place to the other. So that is what current is, flow of charge. So in the conductor, it is the flow of electron. So it goes from one place to another. Okay, in both the cases, electron is moving in this direction. So in the first case, if you see, this blue one is neutral atom. Okay, so inside the conductor there is not only free electrons, but there are lots of ions and neutral atoms also, as discussed earlier. Okay, so when potential difference is applied, when the electron are pushed from one place to another because of the potential difference, while traveling, it will encounter collision. They are going to collide with these ions sometimes, and sometimes with these neutral atoms. So that means electrons are not able to freely go from one place to another. There is some obstruction, and this obstruction, we call it as resistance. Okay, okay, so let me name this as conductor 2. Okay, and here if you see, there is free electron, of course, which will be going from one place to another. But if you look carefully here, you will see more numbers of ions and neutral atoms in this conductor too. So that means this electron is going to face a higher collision. Okay, so a higher collision with these neutral atom and ions. So higher collision basically means more resistance. So that is why when you change the material like from copper to silver, so that means some of them have a greater number of ions and neutral, more collision, so which is your more resistance, and some of them have low number of neutral atoms and ions, which means lesser collision. Okay, and less resistance. Okay, so I guess you understood what is the meaning of resistance in electricity. So it basically means hindrance or obstruction to the flow of charges in the conductor. So then when it goes from one place to another because of the potential difference applied across the conductor, it has to face many collisions with these ions and neutral atom, which gives rise to the resistance. And if you see, if there is a greater number of ions and neutral atom, then there will be higher collision, which will lead to more resistance. Okay, and the SI unit of the resistance is ohm, and it is the symbol is written out here. Okay, so whenever you see some 5 ohm, so that means it is basically talking about your resistance. Okay, which is your obstruction. So 5 ohm and 6 ohm, if you say, then this 6 ohm will be a greater hindrance to the flow of current, or in other what we can also say charges. Okay, so out here you can see I have written a magic triangle. Okay, so and in magic triangle, you have to divide this triangle in three half, as like I have made. In the top part you are going to write voltage, in the bottom you are going to write I and R. And now you can see how we can use this magic triangle. Okay, say for an example, now you know the top part is V, this the left side it is I, and the right side it is R. So if something is missing, if you have to find something, then you can simply use this magic triangle. So say for example, in this first case the voltage is missing, so that means voltage will be I times R. Okay, so this will be giving you the first equation. So see, so how simple it became. So if you do not know V, then you simply multiply I and R, you are going to get voltage. Okay, In the second case, you see, we know voltage and current, but we know voltage and resistance, but we do not know what current is. So simply you make current as a subject, so and then you are going to divide V by R, so that is going to give you another equation. And in third case, we know voltage and current in a circuit, and but we do not know what R is. So therefore you write or make R as a subject, and then you can write V by I. Okay, so in this way you can determine any unknown parameters, okay, from the Ohm's law, and also you can remember the equation for Ohm's law. This magic triangle is going to help you solve many problem. Okay, so let me give you one example out here so that you can remember it. Okay, so suppose V is given as 2 volt and resistance is given as 5 ohm, and then the current is not known. Okay, so then which magic triangle you are going to use? So current not known means the second triangle. So I, okay, I is not known, so simply you divide B by R, so V by R. So then I is equals to 2 divided by 5. Okay, so which basically means this will be 0.4 ampere. Okay, okay, so this is how you are going to use your magic triangle. Okay, so now let's discuss more on resistance. Okay, so basically we have defined resistance and also seen what actually is responsible for resistance. Okay, so define it again, in obstruction or hindrance to the flow of charges, or to the current. Okay, obstruction or hindrance to the flow of current or charges. Okay, so that is your resistance, which we have already discussed. So here we are going to actually discuss different factors which are responsive, which affects the resistance in a circuit. Okay, so first of all is length, and we are talking about the length of the conductor. Okay, so first let me define it. So resistance of a conductor is directly proportional to the length of the wire. So basically this statement is saying that if you increase the length of the conductor, then the resistance is also going to increase. Okay, so what will happen if you're going to increase the length of the conductor, then it will also result in increase of the resistance. Okay, so to see it, you can see this example. So again, consider this as a conductor 1 and this conductor 2. So the conductor 1 is having a length L1 and conductor 2 is having a length L2. So and then you can clearly see L2 is greater than L1. So when the electron have to go from one place to another, so in L1, since the length is shorter, it has to face less number of collision. Okay, less collision. Okay, so less collision, and less collision means less resistance. But if you compare it with the other conductor who is having length L2, which is much greater than L1, so then this free electron, when going from one point to another, so the number of collision is also very very high with the neutral atoms and ions. Okay, so that means this is high number of collision, higher collision. So higher collision basically means higher resistance. Okay, so now you can understand why when increasing the length of the conductor, the resistance will also increase. Okay, so mathematically we can write R is proportional to L, because if L is going to increase, the R is also going to increase, and they are in a linear relationship. Okay, that means if L is going to be doubled, then the R is also going to be doubled. Okay, but there are more factors which is responsible for changing the value of resistance. So let's talk about other factor. Okay, so the next factor is cross section area of a conductor. Okay, So let's see what is going to happen when you increase or decrease the cross section area. So resistance of a conductor is inversely proportional to the cross section area of a conductor. So inversely means uh, that means if you increase cross section area, the resistance is going to decrease. First, let us see out here what is going to happen, and then we can discuss it. Okay. I have made two conductors, so basically assume they both have same length. Okay, so there is no change in length. So this is also L, and consider this is also L. But you can clearly see the cross section area, this area out here, and the other this cross section area here, and this cross section area is very different, A1 and A2. Okay, so A2 is greater than A1. Okay, so A2 is clearly greater than A1. So what is going to happen is that you see there is very small space for electron to travel in this conductor 1, if I say. Okay, but there is very large space or a huge space between these positive ions and neutral atoms for electron to travel. So this is your say conductor 2. If you compare conductor 1 and conductor 2, then in which case the electron can flow easily. So obviously you will say the one which is having a greater cross section area. So if the electron can flow easily, that means there is less obstruction or less hindrance. Okay, so and if the electron cannot move easily like this in the first conductor one case, then it means higher collision and higher resistance. So therefore see how increasing the cross section area will give more space for electron to easily flow inside a conductor, and that is how it affects the resistance. So that's why if you increase the resistance, if you increase the cross section area, then it will result in decrease of resistance, always remember. So then mathematically we can write this R is inversely proportional to the cross section area. Okay, so now we have two equation. Okay, the first, R was proportional to L, R is proportional to L. That means with the increase of length of the conductor, the resistance will increase. And next factor is, if you increase the cross section area, then the resistance will decrease. So which will give us the equation R is inversely proportional to A. Okay, so from equation 1 and 2, if we combine these two equations, then I can write R is proportional to L and inversely proportional to A in a single equation. And remove this proportionality sign, you have to use one constant. This constant we call it as rho. Okay, and rho, and then it's the symbol of rho, and it is resistivity. So till now we were discussing on resistance, but this rho out here, the proportionality sign or a constant that we have introduced, is called resistivity. And resistivity is different from resistance. So for resistivity we are going to discuss in our next lecture. Okay, thank you.